Okay, okay, I'll start now. Hello everyone.
Yeah,
Good afternoon. Okay. So before I start the presentation, let me just do a brief introduction about myself. So my name is Ken Yong. Okay, I'm from Keysight Technologies. So I'm basically taking care of the area we call general electronic measurement segment. So in this area, we are actually covering the IoT application. So which brings the objective of today. So I will share a presentation on topic of this IoT wireless test solution. So for today's presentation, I'm going to cover two solutions from Keysight. So which you can see from here, the IoT 0047A and IoT X700A. So these two solutions are meant to address the challenges in the regulatory testing and also the IoT end devices testing. Okay, so uh, I I will leave a slot for Q&A at the end. So you may raise your question if you have any at the end of this session. Okay, so let me just quickly go through the agenda for today. So to kickstart this, I'll give a brief overview about what's happening to the IoT and also the Wi-Fi. What is the trend for Wi-Fi right now? Okay, and then I'll covering on the regulatory testing on the ISM band. So what do you need about what do you have to know about this wireless regulatory testing and an update on Wi-Fi. So I'm not sure if you heard of this Wi-Fi 6E. This is the latest Wi-Fi standard that is going to be announced very soon. Okay, and how is our solution helps to overcome the challenges? So I'm covering this IoT 0047A and also IoT X700A. So how can we address the challenges in this IoT application? And I'll wrap up with this Q&A session at the end. Okay, so let's start. Okay, so for this IoT, I believe everyone should be very familiar with, right? Internet of Things. So the Internet of Things, the volume forecast is massive. Okay, you can see from here. So it is forecast to achieve 125 billion devices are connected. Okay, connected to Internet by year 2030. That's about 8 years from now. So it has a compound growth like 12% a year. Okay, so uh, it's no surprise. Okay, each one of us, we are actually carrying more than two IoT devices a day. Okay, we we are carrying it every day. Okay, with our hands or in our bag. Okay, and the application is actually growing. Okay, so at the beginning, we can see that the IoT application are mainly a very consumer based. So the applications such as the wearable, so your smartwatch and your home entertainment system, all those are smart home application, and even in the office, smart offices. Okay, or you may use it for personal healthcare monitoring. Okay, so those are the start of this IoT application. But now it has been slowly transformed to go into more and more application. So you can see the new application are actually going to smart healthcare. It's not or for consumer anymore. It goes into the healthcare infrastructure, industrial application, make use of this smart sensor, smart metering, and even the clothing. Okay, so the application is growing rapidly. And I believe you guys should know, right? So wireless IoT is actually does not about it's not about a single technology. So wireless technology is of course a key enabler to support the IoT application, but they are actually supported by many technologies, which some of that we are quite familiar with. So in this chart, you can see an overview of the technologies that are available today. So those are in blue are the already mature technology that has been used a billion every year, and the technology in red is actually in emerging technology. So we can also categorize it by the distant area of the network. So for proximity, so we can see that we use a very close range the application. We use this for payment system. Okay, and on uh on home area. Okay, so for the space less than 5 kilometers, so you can see that there are technologies like Bluetooth, Zigbee, and Wi-Fi is actually very popular for home use, or even the office use, or even the shopping mall. You can see Wi-Fi is there. Okay, and for the area of application that is wider than 5 kilometers, that we need to leverage the cellular network, okay, for the connectivity. So in this space, we are seeing the uh, technologies such as this MBIoT, the LTE-M. Okay, so in this area, we typically call it a low power wide area network. Okay, but for today's application, today's focus, we will be talking about unlicensed band in 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. So which mainly in this range, in this application range. Okay, so Wi-Fi is, or wireless LAN is actually should be very familiar with. Okay, so we have devices connected to Wi-Fi in daily life. Okay, so it's essential. I believe this is our essential way of connect our devices to internet. And Wi-Fi is actually not a new thing. So it has been started since 1999. Okay, so you may see the terms such as the AO2.11b, AG and N and SC and AX. So as the evolution keep going, so it may be difficult for us to remember with all these the name. So started from AO2.11n, so we name it as Wi-Fi 4, and AC is Wi-Fi fifth generation, and AO2.11x we call it Wi-Fi 6. So it is easier for us to remember. So just increment of number. So and not by the character. Okay. So and the evolution is actually uh due to the data throughput requirement. So alongside with the evolution from 5G. Okay. So for now, I believe the market is up to this AO to the 11X right now. So if you go into the IT market, you can see a lot of router are actually for AO to the 11X. But of course, if you want to make use of this AX capability, so the device also need to be AX equivalent. Okay, and as you may know, Wi-Fi is actually making use of the ISM band. So an ISM band are actually refer to the 2.4 gigahertz and 5 gigahertz. Okay, and ISM band is actually a license-free band. So any device maker can just design their product and deploy the product in this ISM band. So as you can see, it will be going to be more and more congested. So more and more device to fit into this ISM band. So you get more interference, you get lower data rate. So for that reason, so there is actually a new announcement of the ISM channel. So which is the 6 gigahertz. So the advantage of this 6 gigahertz ISM band, you can see from the picture here, it has this 1.2 gig of bandwidth. So for 2.4 gig, we only have 100 megahertz uh, bandwidth to be shared with all of the user. and for 5 gig we have 750 meg. But for 6 gig, so we actually got a lot more. We have 1,200 megahertz. Okay, but so this 6 gig is also a native usage by such as a satellite or terrestrial link. Okay, so the application has already been assigned to a satellite and terrestrial link. So in order to avoid and protect these incumbent user, so there are actually new testing requirements coming up. Okay, uh, so the regulator they are going to introduce new testing requirements. Okay, and new frequency coordination to protect all these incumbent applications such as satellite and terrestrial link. Okay, so therefore, okay, so there is a regulatory responsibility to come out with all these new testing standards. Okay. Um, so a brief overview on this product life cycle. So this sequence flow actually shows a typical devices product life cycle and the type of testing that is required in each stage. So at each stage, I also show the challenges the engineer may face and what is the resolution to it. Okay, so during the development process, so the engineer need to perform extensive testing uh, to on all part of the design, such as the RF modules, okay, the protocol stack, okay, and the software simulation. And maybe when you come to this design verification phase, you need to connect the component together and test it as a system. Okay, once you have complete the development phase, the next is that you need to go through a series of the complex testing to achieve the compliance regulatory testing. So this is very important because for every device to be market into a region or country, so that that particular device need to obtain a local or the industrial regulatory certification. So it doesn't care where you manufacture the product. As long as you want to sell into the region such as Thailand, you need to get the Thailand government or the certification to be able to market into the local uh, local market. Okay. So and for our focus, so we will for the focus of today, so we're mainly talking about this wireless regulatory testing. Okay, so mainly ETSI and FCC. So coming to this regulatory, so actually every country or every region or every industry they have their own certification or regulatory authority. Okay, but out of so many regulatory, there are two famous 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 standard in this world. So this is actually the FCC from United States and also the CE or IED from Europe. Okay, so these two regulator they actually define their own standard for a lot of the testing. So not only for 2.4 gig and 5 gigahertz band. So, and their standard has been widely referenced by other local regulatory. So it is important to understand and to understand the needs and requirement from FCC and CE so that we we can easily know what is the challenges and what are the requirements to get certificate for your product. Okay, so let's take a look on this FCC and ETSI standard. Okay, so of course there are many standards. So for today's topic, I'll just focus on the 2.4 gig, 5 gig, and 6 gig unlicensed bands only. Okay, so first the FCC. FCC have two standard for this unlicensed band testing. So it named as a Part 15.247 and Part 15.407. As you can see from here, so it mainly by defined by the frequency band. So it doesn't care what technology your device is operating. It doesn't care if it's Wi-Fi, Bluetooth, GSM, 3G. Okay, no. So as long as your device working in this frequency range, you need to your device working in this operating frequency range, and you want to market into FCC region such as US, you need to get certified by this standard. And Part 15.407 is mainly handling in a 5 gigahertz range. And you can see this is the new adoption, new add-in to the standard. This is actually the new 6 gigahertz range. And for the European standard, so you can see start with EN300-328, EN301-893, and EN303-687. So for 2.4 gig, so you need to go through this EN300-328 standard testing. For 5 gigahertz, so this is the standard that you need to go through. And for the new 6 gigahertz, the European region, they actually come out with a new draft. Okay, for FCC, they just add the new frequency into the existing spec. But of course, they will have a newer version of this standard. Okay, so for your information, for the requirement of this 6 gigahertz testing is still in a draft mode, but we expect it will be announced sometime now. So it's very soon. So for Keysight, we already announced our 6 gigahertz solution in last December. So our solution is ready to support this new standard. Okay, so another information on this standard. So the standards keep on evaluate across the technology evolution. So for example, on this ETSI EN300-328, so it's actually started in 2006. So this is the version 1.7.1. For this version, it only covers the Bluetooth 2.1, or last time we call it the EDR, Bluetooth EDR, okay, and Wi-Fi version B and version G. As the technology keeps on evaluate, and you can see there are more and more capability or tests that is added into the spec. So for example, you add in the new Wi-Fi and adaptivity testing, receiver blocking. So this is the current version, version 2.2.2. Okay, this is the latest version as of now. But it will keep on upgrading by adding more tests. Okay, so what is about this ETSI or regulatory testing? So now maybe we take a look at this regulatory testing. What is all these are about? Okay, and why it gives us challenges in running the testing. So first, let me pull out this ETSI test draft. So as you can see, so it has a test item 1 to 18. So test item from 1 to probably 12 is actually we call conductor testing. And 13 to 16, this is actually we call the signaling testing, where you need to connect the device with a radio to perform some signaling testing. And this item 17 is the dynamic frequency selection for only applicable for 5 gigahertz range. So it doesn't really care what technology are you in. So whether Bluetooth, Wi-Fi, Zigbee, okay. So it actually segmentized by the frequency. Okay, so first thing, if you are the engineer, if you look at this ETSI standard, so you may find, okay, so there are large matrix. Okay, you need to test. You need to know what's your device capability, and then you need to map according to the matrix here. So it will if you give you a large test combination. Okay, this is the first challenges as the engineer. And the second challenges is you really need to understand how each of these tests being performed, and you need to perform according to the setup defined by the ETSI standard. So, for example, adaptivity. So, what does this adaptivity means, and how you need to perform? So, actually it's not easy to do it manual. So, uh, in fact, it is much more makes sense to do it using automation. Okay, as some of these tests are actually taking quite a long time to complete. Okay, and to complete the testing, sometimes it needs more than one instrument. Okay, it's just not not only you need a power meter to complete it. Has sometimes you need a signal generation to create a signal. Okay, or a golden radio to establish a test link, and then a power meter or a signal analyzer for the measurement acquisition. Okay, so once you complete the testing, the next challenge is how do I generate a report? How do I conclude the result? So these are challenges for engineer. And if you look at the FCC test, so it has a less test item. For example, it does not have all this receiver blocking testing. So it has a less test item, but it is still need to keep track. For as an engineer, you need to know what are the latest update. As I mentioned, the standard are actually a living document. It keeps on adding more and more test item uh, uh, across time. Okay, so it is actually you need to really understand each of these tests. You need is highly skilled compliance engineer to run it, and manual is a tedious way to do to do it. Okay, so what you really need is actually an automation solution to help the engineer to perform the test efficiently. Okay, and if you are testing your device in a 5 gigahertz range, so this is the item dynamic frequency selection is a one test that you need to complete. Okay, so DFS is actually a function of this 5 gigahertz Wi-Fi frequency. Actually, this is actually generally reserved for radar applications such as this military radar, satellite communication, or this weather radar. So these DFS channels actually varies from country to country. Each country they allocate a different DFS channel. Okay, and the main benefit for Wi-Fi to make use of this DFS channel is to increase the number of these Wi-Fi channel. Okay, and if you are using this DFS channel, so it is a must. It's a mandatory to perform one algorithm called uh, channel availability check. Okay, to make sure the channel is empty before you start to transmit a signal. Okay. So now let me just throw a question out. So how long does it take, okay, for a very experienced engineer to complete a 2.4 gigahertz testing only for this EN300 Of course, you don't have to answer. So I'll give you the answer here. So if you do it manually, okay, it takes days, okay, weeks, 1 to 2 weeks to complete this 2.4 gig testing. Okay, with automation, you still need to do it in days, but it improved from 1 to 2 weeks to 3 to 5 days. So you can see how long it really takes, how critical it is to have an automation software to help an engineer to complete the regulatory testing. Okay. Next, I will just share the Keysight solution on this wireless regulatory testing. Okay, so this is how Keysight solution looks like. So first, okay, our solution is by the name of IoT 0047A. So we are making use of Keysight standard X series signal generator and also signal analyzer. So if the if the test lab already equipped with this solution, so they can actually uh, reuse this instrument for the regulatory test solution. Okay, and second hardware is we call it the signal conditioning test set and also the MIMO power test set. These two instruments are actually dedicated, is designed to support the regulatory test set. And this is our software, so we need to use the automation software to complete the testing. Our software is straightforward, so we have the software solution for ETSI, the software solution for FCC testing, and the software solution for the dynamic frequency selection. Okay, so now let me show you a brief block diagram of our IoT 0047A. So typically we need to know this is your DUT. Okay, so we need to know how many physical test ports are coming out from the DUT. So if this is a single antenna, then we only use only one port. And if there's four antenna, for example, an AP. So if you're testing a wireless LAN AP access point, we have four antenna. So you can connect to all four port of these MIMO power test set. So our MIMO power test set has four ports. And if there's a need to support up to 8 antenna, we can extend to another X750 for 8 transmitter, 8 antenna support. Okay, and according to ETSI regulation, so we need to measure the power in time domain simultaneously. Okay, so for one antenna, it can easily be done, but if for 4 antenna, you need to make sure the measurement done simultaneously. So we include the power meter in this MIMO power test set to serve this purpose. And we have this X8749A. So the purpose of this box is to support the signal conditioning for the receiver testing. So whenever you want to perform the blocking test, adaptivity, or the dynamic frequency selection, so you need to connect with this signal conditioning test set. So this is our X series instrument to support on the signal generation and also signal acquisition. And this is our software. So everything will be run according to the software from here. So this is how our software looks like. So we have a modern GUI, okay, and it's very straightforward. When you click the start on this software, first you need to do is select what are the regulatory standards that you want to perform. So just click on this, either ETSI, FCC, or DFS. And when you select, for example, select ETSI, the next is what are the tests you want to perform. Of course, you can click multiple tests if you want to perform, or click everything in here to let it run automatically. Okay, so it has a very straightforward and clear procedure to help an engineer to perform the test. And when the test is finished, completed, so the next thing the engineer need to do is compile the result. And before he compile the result, he may want to go through again on the test result, so he can view the result in the software to see how is the status. Is it pass or fail? Is there a need to troubleshoot on the fail? So It's very easy to read, and then we provide a very good charting, and then to help an engineer to complete the, the documentation for the test result. Okay, so the key site solution is actually a scalable solution. So you sometimes you may not need to test all the list from test item 1 to test item maybe 18. Okay, so sometimes an engineer he only want to support the conductor test. So for ETSI example, for example, which is a test item 1 to test item 12, so he may not need to uh, buy everything. So you can start with one signal analyzer and one uh, MIMO conditioning test set. So this setup is enough to support the conductor test. And when he want to perform the receiver test, he can get this configuration. So which has two signal generator and also the signal conditioning test set for the adaptivity, okay, and the software. And this is a dedicated dynamic frequency selection test station. He can set only purchase this configuration to complete this DFS testing. And of course, when everything combined, you can build a complete regulatory test station. So the it is a configurable solution. So to help customer to save the cost when trying to complete a certain regulatory testing. Okay, so now I want to also highlight some of the test challenges along with this regulatory testing. So just now I mentioned the adaptivity. So adaptivity testing is required in ETSI. So adaptivity test is actually a method, okay? Because Wi-Fi or Bluetooth they're actually operating in ISM band. So where there are many users to share in the same bandwidth. So adaptivity is a method to allow the network terminal to share the media. Okay, so through detect before transmit method. So the device it need to detect if there's the energy RF energy in the channel that he is about to transmit. So if let's say energy is detected, so it will actually stop for a random time before the next transmission, next detection. Okay, so the device can only transmit the energy, transmit the signal if the there's no energy, RF energy is detected. So if you look at this algorithm, you can see that actually it will take a long time to you need to collect a large sample in in order to complete the whole testing. Okay, so just for example, for this AO2.11 B, G, and N. So in order to complete the adaptivity for this B, G, and N 2.4 gig, so it easily takes 6 to 8 hours. Okay, and our solution it can provide a great value to help engineer to automate the whole adaptivity testing and also help them on the data analysis. And on the test challenges two is about the DFS. DFS has a similar role like the adaptivity testing. You need to detect if there's any radar signal before you can transmit, because radar has a priority to be operate in 5 gigahertz band. So, and if you look at the picture in here, so once if you detect there's a radar signal occupy the channel, so what your device need to do is if you can either move to a different channel for transmission, or you wait for 30 minutes. So by looking at this, so the DFS test alone it takes days of measurement time. So our solution value is actually to help the engineer to automate the whole testing without sitting in front of the test station and waiting for the result. So it can help to shorten the days of testing to minutes. And the third challenges is frequency hopping. This is mainly for Bluetooth. So frequency hopping is another method actually to help reduce interference on the same ISM band. So but for frequency hopping testing, the challenges is that there are actually many channels. It hops around. So you need to have a longer detection period and higher sample of capturing in order to do this frequency hopping analysis. So our solution value here is help the engineer to perform the automation testing and also the data collection for the analysis. And the last challenges, so on the diagnosis part. So a solution our solution is great to help the engineer on the troubleshooting purpose. So what for take for example, you run 3 tests, but you run a couple of tests, but out of the at the end of the test you see there are 3 tests fail. So do you need to run everything again? No, right? So it's tedious to run everything again. So with our solution, you can just rerun the failed test, okay? Just to look at how this test fail. So we have the modern software GUI which we enable the engineer to select the parameter accordingly, okay? And additionally, so our software are always update with the latest regulatory requirement. So you do not have to worry that the test is actually out of spec or does not meet the regulatory purpose. Okay, so I'll move to the next topic, which is on the wireless end device testing. So for this IoT end device testing, so maybe let me just give an overview on how the background of why it matters. Okay, so we believe that the radio standard is evolved very rapidly. Okay, so from the device maker perspective, so they need to really come up with to achieve the first to market. Okay, they want to capture the market. They need to quickly release a new product to capture the market, and the volume for IoT is massive. Okay, and if you look at the device trend, so it is getting smaller and smaller. So the implication of the smaller or miniaturized trend is that the device sometimes it does not have any I/O connection port. So it becomes difficult for the device maker or the test house to actually perform testing, right? So by looking all this, so there is a growing need that they need a simple testing, okay? OTA measurement, over the air measurement, because there's little or almost none connection port, okay, to support the research and development as well as the manufacturing. Okay, so Keysight we study the market trend and we believe the solution needed to address this area is a simplified test setup. Okay, a simplified test setup that is enabled to support the over-the-air testing, and also we are able to test the device in operation mode. Okay, it's not test mode. So most of the device you see today is actually we test in the test mode. Okay, but now we want to speed up the process. So we support the testing in signaling mode. Okay, so that is to ensure the final end product, the actual quality. Okay, so to support the high volume testing, so we come out with a multi-device parallel testing configuration. In fact, this is we this is a key site, we actually filing for this parallel testing patent. Okay, so it's still pending for the approval. Okay, so we understand the popular format of these devices are in Bluetooth and Wi-Fi. So, and this is our solution. So you can see from here, this is our X8700A, okay, solution that is to support this end device over the air testing. Okay, how can our solution to address the challenges or the pain point? So the pain point number one is that during the design verification, a lot of the designer or device maker they use these uh, wireless tester, and most of the time they actually do direct testing to the device. But nowadays they are facing the challenges of there's no antenna port anymore. Okay, so our solution is actually designed to perform the testing over the air. Okay, so this is one area we try to resolve. And second part is on the manufacturing. So in on the traditional method, so you are either doing the testing in the test mode or you're doing testing in the pairing mode. Okay, so it actually quite slow. So our solution have an innovative way to support parallel testing up to 4 devices at the same time. And on the third pain point is that on the regulatory testing, especially when you talk about the adaptivity, okay, the signaling testing, you probably need to use a golden radio to establish the connection. So, but when you use a golden radio, you do not have actually a control over the device, right? The golden radio, right? So by using this IoT 8700A, so where you can send the Skippy to control the device as well as to establish the signaling link with your DUT. Okay, so this will help the test house to perform the signaling testing. Okay, so this is our solution IoT 8700A. So it is target to support Bluetooth and Wi-Fi. So we can support the 2.4 gigahertz range and also 5 gigahertz range frequency band. So the unique feature of this is we can support 4 DUT parallel testing. Okay, so let's take a look at this. So currently, I believe there are many devices, device maker or test house, they're actually doing the sequential testing. So usually you need to perform the receiver testing on the transmitter testing. So for if you are to perform 4 DUT and each DUT takes about 30 seconds. So to complete all 4 of them, you probably need 120 seconds. So this is just a very simple example. And how can our solution address this? Is we connect to 4 of them at the same time. So our tester can connect to 4 DUT and we can run the testing to four DUT at the same time. So if to complete the transmitter and also receiver test it takes about 30 seconds, then you can complete 4 of them also about 30 seconds. Of course, there will be some overhead, so it will be 30 seconds plus. Okay, so this is a innovative method to improve the manufacturing time. And another way device manufacturer can do is to convert it into a ping pong testing. So by adding a RF switch. So a ping pong method it enables the one device to be testing while the other device is under operator handling by changing the device. So when one device finish testing, it quickly switch to the other device for testing. It will save the handling time. Another application that we can make use of this IoT 8700A is the Bluetooth UUID discovery and read byte. So for this is particularly for Bluetooth application. So Bluetooth application come with this UUID, which is an identifier. So this identifier contains some serial number, manufacturing date, some, for example, the battery level. But of course, it requires the device to allow the permission for read and write. So uh, so by having these features, it actually helps the manufacturer to perform the serial number writing without a hardwire connection. So for example, previously a customer they usually write the Bluetooth serial number through some UART or I2C connection. But with this over the air, so they can complete this together during the TX and RX testing. So our solution also support this wireless LAN throughput testing. Okay, so for this wireless LAN throughput testing, we actually make use of this iPerf methodology. So in which the tester will always act as a client, okay, and the DUT will be act as a server. So we will be requesting, we will be sending packet to the DUT and request the DUT to send back the packet. So by completing this loopback testing, we can calculate the throughput testing for in the wireless LAN test mode. So this is our new application. So we will be releasing more and more application information for the wireless LAN testing. Okay, so a quick briefing on our solution. We actually have two different models. So one we call it as 8720A, which is for the single DUT testing. So the other one is the 8740A. So this one it will have these multi DUT features. Okay. And our solution come with two different type of software. So if you are the very good in the programming, Skippy is by default it comes with a Skippy command. So if you do not like to write to write the program to control using Skippy command, you can either use this GUI. So it gives a very easy to use and graphical display to control the device and make some measurement uh, to get the live measurement from from the DUT. Or if you are intended to be used for manufacturing environment, we also have this XAir 8723A. So this is actually a measurement suite or a library. So we have we built the test library for this solution. You can just drag and drop the test step that you intended to perform, and then run this in the production manufacturing. Okay, so because we intended for the over the air testing, we also there's some additional accessory that we can offer to the customer, which is a shoebox. So we offer three different type of shoebox, depends on the number of DUTs that you intended to be tested and also the size of the DUT. Okay. Okay, with that, that's the end of my presentation. I actually welcome if you have any questions.